Hi everyone, this is Natasha Masando and welcome back again to our Lab 7 of K-means clustering. So as we can see, we already have our data set, and today we're going to look at measuring similarities between clusters. And so just to kind of give you an educational background, we have like 4 methods that we use to plot new points, and these are called like centroids. So we have the single linkage, which is a closer observation from 2 clusters, and then we have complete linkage, which is the farthest points of 2 clusters. And then the third one, we have average linkage, which is whereby we look at all paired distances and take an average. And then the last one is the fourth method, which is average group linkage, and this is whereby we take the centroid distance between 2 clusters. So looking at our given data set, we were given 3 center points, and these center points are A1, which is 2.10, B1, which is 5.8, and C1, which is 1.2. And this means that our K value equals to 3 because we have 3 different cluster points. And so we're going to use them as our initial center points, so that we can apply the Euclidean equation to calculate the distance from our chosen given center points to see what cluster new points we'll place for each point. So these are the points A1, A2, A3, B1, B2, B3, C1, C2. So the equation that I'm going to use is this one, which means parenthesis x1, y1, and b equals to x2, y2, defined as p, parenthesis, open, a, b, close parenthesis, equals to x2 minus x1 plus y2 minus y1. Using the points x1, y1, which is this one, and then the mean x2, y2, which is the distance that we're given here. So to begin with, it's a lot of work, but it's worth it. So to begin with, for example, in A1, we're given 210, right? And our center point, which is this one, is also 210. So we say P, open parenthesis, A, B equals to x2 minus x1 plus y2 minus y1. The point mean 1, which is the first point, that's what it means by 1, is x2 minus x1 plus y2 minus y1, which equals to what? 2 here. This is x2 minus x1, so it'll be 2 minus 2, and then y2 minus y1, which is 10 minus 10, and this gives us 0 plus 0 equals to 0. So I repeated the same steps for each and every point. As you can see, I went on to A1, mean 2. So A1 was to use the same point, which is 2.10, and then I went to the the distance mean 2, which was B1, 5.8. And when I plugged in the same numbers, using the different mean, I got 3 plus 2 and got 5. Then I did the same thing for mean 3, which is C1, 1,2. When I applied it, it gave me 1 plus 8 equals to 9. Then I repeated the same process for A2, which is the point 2.5, and the mean that we're given the first one, which is 2.10. Did the same equation, which gave me 0 plus 5 equals to 5. And then I did the same thing for A2, mean 2, which is the 5.8, and that's the B1 here, using point. So I was going like this: 5.8, A2, and then 1.2 to 2.5, and then did all the calculations to get the different new center points. So I'm gonna flip the page. Oh, it's a lot. So as you can see, I continued down to A3 with all my points, and then to B1 here, and we have the B2, did the same calculations using the same means all throughout to C1, C2, which was the last point that we were given. So to move forward, we're going to apply those points and create a cluster. So this cluster we're going to create is pretty much a schema. So I'm going to first plug in the numbers or the new different distances that I received, and then we're going to show you how the cluster works. So let me go back here a little bit in order. So as you can see, for the first one we got 0, right? So it's going to be 0. If my pen can write, pencil. So we got 0, 5, 9, and then we got 5, 6, 4, and then we got 12, 7, 9, and then we got 5, 0, 10, and then we have 10, 5, 9, and then we have 10, 5, 7. So I know the order, that way it made it easier for me to write it down. Then I have 9, 10, 0, then 3, 2, 10. So 3, 2, 10. So for me to know which cluster each of these new points belong to, we would look at the point, for example, 2.0. So the closest point to 2.0, looking at all these different new distances, is 0. So that means this point belongs to cluster 1. And then we do the same thing for point 2.5. The closest, which is usually the minimum, is usually like the minimum distance, which is close to the given point. So looking at 2.5, the closest one is 4, so it belongs to cluster 3. And then 8.4, the closest one is 7, so it's cluster 2. Then 5.8, the minimum is 0, so it's cluster 2. 7.5, the closest one is 5, so it's cluster 2 as well. 6.4 belongs to 5, so it's cluster 2. Then 1.2 is close to 0, so it's cluster 3. And then the last one, 4.9, is close to 2, so it's cluster 2. So these clusters, we then apply them to the schema. So the schema is where we're going to write down all the new points that belong to each cluster. So if we look at cluster 1, we see that we only have 2.10. Point 2.10, so we put 2.10 here. And then we look at cluster 2, we have 1, 2, 3, 4. So these are points 8.4, 5.8, 7.5, 6.4, it's actually more. And then the last one is 4.9. And then in cluster 3, we have 2, which is point 2.5 and point 1.2. Sorry, I forgot to put parentheses. Okay, so once we have the new cluster, we're going to use it to create, pretty much we're going to repeat the same process. So the thing that we're going to do is that we're going to calculate the average of these clusters, and then by calculating the average for each cluster, we're going to recompute the new cluster centers. So that means it's going to replace this other given cluster points that were given as our centroids. So we're going to change that. So for cluster 1, we only had 2.10, right? So that means it's going to be calculated this way. So I don't have, you know what, let me use this scratch paper. So it's going to be, for example, we only have 2.10 in cluster 1. So that means that same point is going to remain the same because it's only 1. But if we look at cluster 2, we have 8.4. So the way you calculate it is you take an average of all the x's and an average of all the y's. So looking at the x's, we have 8 plus 5 plus 7 plus 6 plus 4. Then we close our parentheses and we divide by 5 because we have 5 different points altogether. And then we do the same thing for the y, so it'll be comma. And then we see we have 4 plus 8 plus 5 plus 4 plus 9. And then we divide by 5. Same thing. So altogether we get a total of 6.6. So this is going to be the new point. So that'll be the new point right here, 6.6. And then we repeat the same thing for cluster 3. So in cluster 3 we only had 2 points, right? So we have 2 for the x plus 1 divided by 2, since there are only 2 points, comma. The y's we have 5 plus 2, close parenthesis, divided by 2, and this gives us it gives us 1.5. Let me write it nice and neat. So this gives us, what's going on with my pencil? This gives us 1.5, comma 3.5. That's the new center point. And as you can see, that's what we have here. Let me go back. 1.5, comma 3.5. So I repeated the same process again to calculate the distance to get the new center point. So as you can see, I went here. I did x1, y1, using the same point since it was only 2.10. And then my new mean, well, it's the same one. It's the old one, but it's the new one now, which is 2.10. And I plugged in my numbers and I did the same thing. 2 minus 2 plus 10 minus 10. It gave us 0 plus 0 equals to 0. Then I plotted the new 0 point here. Then I did the same thing, point x1, y1, 2.10 with the new point, which is 6.6. So it gave me 6 minus 2 plus 6 minus 10, which gave me 4 plus 4 equals to 8. And that was my new distance for mean 2. And for mean 3, I did 210 as the point and 1.5, 3.5 is the mean 3. And it gave me 1.5 minus 2 plus 3.5 minus 10, which is 0.5 plus 6.5, and it gave me 7. And I plugged my 7. So I repeated the same steps, as you can see, for each and every new point using for each and every new mean distance to apply towards the same point so that we could get a new centroid. And I did the same thing for A3, B1, B2, and B3. And so with the new one, we were able to we're going to do the same thing, which is find the distance, which is close to the cluster point. So for example, if we look at 2.10, closest is 0, so it belongs to cluster 1 again. And then the closest here to 2.5 is 2, so it belongs to cluster 3. The closest here to 8.4 is 4, so it belongs to cluster 2. And then 5.8 it's closer to distance 3, so it's cluster 2. 7.5 close to 2, it's cluster 2. 6.4 is close to 2, which is the minimum, so it's cluster 2. 1.2 is close to cluster 2, it's close to distance 2, so it belongs to cluster 3. And the last one, 4.9, is close to distance 3, so it's cluster 1. So pretty much to make it simple, the minimum distance, that's the rule. The minimum distance from the point to each cluster is what we use to determine what cluster we place each and every point using the new distance mean. So we do the same thing again. In cluster 1, we only have 2.10. So 2.10 and 4.9. That's our points. In cluster 2, we have quite a few. So we have 8.4. We have 5.8. We have 7.5. Let me see, 1, 2, 3, 4. And the last one is 1.2. So 1.2. And then in cluster 3, we have 2.5. And then we have 1.2. Wait. 1.2. And so in cluster 2, we have 6.4, not 1.2, 6.4. Sorry. Okay. So we use the same points to make up the new centroids. So we're going to do the same thing here on my rough sketch paper. So we're gonna do the average of 2 plus 4 divided by 2, since we have 2 points for the x's, and then comma for the x-axis we have 10 plus 9, so 10 plus 9, and then divided by 2. So we get what? 3.95. Yeah, that's the new point. And then 3.9.5. And then we repeat the same thing for cluster 2. We have 8 for the x's plus 5 plus 7 plus 6. And then divided by 1, 2, 3, 4, divided by 4. Comma, for the x's, we have 4 plus 8 plus 5 plus 4 divided by 4. And this gives us 6.5, 5.25. And then we do the same process again, which is the last one, cluster 3. So we have 2 plus 1 divided by 2, comma, for the y we have 5 plus 2 divided by 2, and it gives us 1.5, 3.5. So pretty much these new numbers will be the new means. So it's just a repetition process. So it'll be 3.9.5, and then second one will be 1.5, 3.5, and then the last one will be 6. Sorry, it'll be let me see here. It'll be 1.5, 3.5. So we just pretty much repeat the same process until we calculate the 4 methods that we learned in the beginning, where we find the average group linkage, the average linkage, the complete linkage, and the single linkage, so we can plot the points that are closer to the new centroid points that we're given as our means. And that's it.